Test, test. Okay, good morning everyone. Welcome to the OneClass channel. My name is Andrew and I'm currently doing stat and math at University of Toronto. And today we'll be going over some commonly asked mathematical questions at both the high school and college levels. And if you need some homework help or tutoring, please check out the links in the description below. So now let's start our session. All right. Oops. Okay. So our first question today is asking us what is the square root of 9? Alright, so let's zoom in a bit. Alright. So what is a square root of 9? So recalling the definition of square root, so the square root of a real number is just a number when multiplied to itself give us back the same real number. So let's write this sentence down. So the square root of a real number is the number when multiplied to itself gives back the same real number. Alright, so now let's go back to our question. We need to solve for square root of 9. We know 9 is equal to 3 times 3. So root 9 is equal to 3 root 3 times 3, which can be also written as root 3 to the exponent of 2, which is just going to be 3 itself. Yeah. So know that we can express the number 9 as the square of 3, thus we can cancel out the square root and the square. Right, so this will be our final answer. Yeah, and we can always check the answer, because so square root of 9 is equal to 3. So let's do 3 times 3. Yep, it is equal to 9. So our answer is correct. Okay, so now let's leave a comment here. Solution is correct. Good job. All right. So our second question today is asking us what are rational numbers? All right. So rational numbers are numbers that can be obtained by dividing two integers. So let's write the first key point down. Obtained by dividing two integers. Therefore, these numbers can be expressed as a fraction. Fraction or in the form of a over b. Right. So an example of a rational number is 0.5. So we got 0.5 here. And this can be expressed as a fraction, which can be either by 5 over 10, or we say 1 over 2. Yeah. So we know 0.5 is a rational number. Things it can be written in the fraction form. Right. So on the other hand, okay, however, numbers like root 2 can now be expressed as a simple fraction. Oops. This should be equal. Hence, it is not an example of a rational number. Yeah. So let's talk about some other examples of rational numbers. And this is 3 is also irrational numbers. Because 3 over 1. Yep. Can express 3. And note 3 is also what we call integer. So integers are those numbers without decimals. So it's like, and it could also be negative. So numbers like -4, -3, -2, -1, 0, 1, 2, 3, blah blah blah, 1000. Yeah, so there are infinity integers. And go back to this question, other than 3, -0.01 is also a rational number. As it can be written as 1 over 100, or -1 over 100. Right. So I think that's all we got for this question. And let's leave a comment there. Solution is correct. Alright. So coming up, our third question is asking us, what is a prime factor? What is a prime factor? Okay. So prime factor, let's write it down here. It is a number divisible only by itself and 1. Yep. So let's write the keyword down. Divisible only by itself and 1. So some examples could be 2, because 2 is only divisible by itself or the number 1. So which means 2 is a prime factor. A prime number. Right. So 3 is also a prime number, since 3 is only divisible by itself or the number 1. And let's say 6, because 6 is equal to 2 times 3. So 6 is not a prime number because it is divisible by the numbers 2 and 3. So not a prime numbers. Right. So these are what we have for prime numbers. And now let's move to the prime factors part from the prime numbers part. So prime factors. So prime factors are prime number factors of a certain number. Prime number factors of a certain number. Right. So for example, the prime factors of the numbers 6 and 2. Prime factors of the number 6 and 2. And 6 and 2 as 3. It's a prime number of, So the prime factors of the number 6 are 2 and 3. Yeah. So prime factors of a number can be calculated when you break up the number as a product of the smallest integer possible. So smallest integer possible. Right, so I think that's all we got for this part. Solution is correct. Right. So coming up, we have our next question. It's asking us, what is root 45? So whenever we come across a question asking us what is root something, we always need to express whenever inside the square root as a product of its prime factors. So in this case, 45 can also be written as 9 times 5, because 9 times 5 is equal to 45. And since 5 is a prime number already, so we just leave it there for now. And we only need to deal with 9. So 9 is equal to 3 times 3. And we can stop there, because 3 is also a prime number. Therefore, 45 is equal to 3 times 3 times 5. Just a very last number of each branch. Right. So now we can apply the square root of it. So square root 45 is equal to square root 3 times 3 times 5. And now let's group them by pairs of the same factor. So left hand side is still going to be root 45. And now we group the 3 together. Right. Because recall that root 3 times 3 is just equal to root 3 squared, which is going to be 3 itself. Therefore, root 45 is equal to 3 times root 5, because we take the 3 out, and that is our final answer. So 3 root 5. Okay, so let's leave a comment there. Okay, so our next question is asking us, is 50 a perfect square? So first let's write down our conclusion. 50 is not a perfect square since it does so I'll just move this a little bit down. Since it does not have an exact square root. Right. So the junior tutor also lists some examples of perfect squares, so let's go over them together. So here are some examples of perfect squares. Okay. So the first column will be perfect squares. The second column will be square roots. And squares for the last column. Alright, so the smallest positive perfect squares are just 1, since 1 times 1 is equal to 1. Therefore, 1 is also equal to root 1. And 1 squared, it just means 1 times 1, so it's just going to be 1 itself. And then we have our 4, and 2 is equal to root 4, because 2 times 2 is equal to 4. Right, so if we got 2 to the exponent of 2, it's just going to be 2 times 2, which is equal to 4. And then we have 9, where if we take the root square of 9, it's going to be equal to 3. And in other words, 3 to the exponent of 2 is going to be equal to 9. And then and then 10 doesn't work since we cannot find a exact square root of it, and 11, 12, 13, 14, 15 doesn't work, and then 16 works. So if we take the square root of 16, it's going to be equal to 4, and 4 to the exponent of 2 is equal to 16, and then will be 25. So if we take the square root of 25, it's going to be equal to 5, and 5 squared is going to be 25, and then it's going to be 36. So if we take the square root of 36, it's going to be 6, and 6 to the exponent of 2 is 36, and 49, take the square root of 49, it's going to be equal to 7, and 7 to the exponent of 2 is 49. And then we have 64. So 64, we take the square root of 64, it's going to be equal to 8, and 8 times 8 is going to be equal to 64. And then we got 81. So we take the square root of 81, it's going to be equal to 9, and 9 squared is equal to 81. And then we got 100, and we take the square root of 100 is equal to 10. So 10 to the exponent of 2 is equal to 100. And yeah, we can keep writing this down, and it will go to infinity. There are infinity of perfect squares. Let's just write a couple more. So 121 is also a perfect square, and if we take the square root of 121, it's going to be equal to 11. So 11 to the exponent of 2 is 1 to 1. And let's just do a couple more. So 144, we take that, the square root of 144 is equal to 12. And 12 to the square, 12 squared is just 144. And yeah, and let's say 225. If we take the square root of 225, it's going to be equal to 15. And 15 squared is equal to 225. So our first columns are the numbers that are perfect squares, and the second column will be the square root of it, and the last column will be the squares. Yeah. So I think that's all we have for this question. So let's see. So now let's leave a comment. Oops. No. I think there's a technical issue, so let's just write the comment again. Oh, correct. So I think those are all the questions for today. And if you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and notification bell below. And if you'd like to submit your own questions, please read the links in the description. Remember to leave a like and a comment and share this video with your friend. And this has been Andrew